This is June 2016, paper 2, question number 7. A man pushes a metal trolley along a corridor towards a lift. Here he is, looking very happy. The trolley has nylon wheels and the floor of the corridor is covered with plastic. The man also wears shoes with rubber soles. As he moves the trolley, the man gains an electric charge. Explain how the man gains this electric charge. So, in order to get an electric charge building up, you've got to transfer electrons. So we've got to mention something about electrons moving. And why would they be moving? And it's because due to friction. And you can say where that friction is coming from. So you could say it's between the floor and the shoes and the wall. You would have said something about electrons. So something about electrons moving, and then the idea of rubbing between two surfaces. If you'd said electrons are like knocked off or rubbed off one of the substances, then that would have got you 1 mark. It's got to be about the transfer due to this friction. I think people are going to go into lots of detail here about explaining how, but you want to say it gains charge because, and remember, if you're using that word explain, you've got to use the word because of a transfer of electrons due to friction. Something like that would have been great. The man presses a metal button to operate the lift. There is a spark, so he gets an electric shock. The spark lasts for this amount of time, and that amount of charge goes through. Now look, it's being nice again. It's saying state the equation. Notice sometimes it says state the equation or state the relationship. It's all about an equation. So in this case, we want to say Q equals I times T. Of course, you could have also said charge equals current times time for 1 mark. Calculate the average spark, average current. So we've got to rearrange it. And that's why it's given us 3 marks this time, because we have to rearrange that equation. And then we've got 0.0017 divided by, now here I think the mistake people are going to make is this is milliseconds. So to get this into milliseconds, I've got to put that 10 times 10 to the minus 3. I could have also divided this, because milli means 1,000th. So a millimeter is 1,000th of a meter. A milligram is 1,000th of a gram. So this is 75,000th of a second. So I could either convert it before, or I can just use scientific notation and put times 10 to the minus 3. And then I should get 0.023, that's a 2. And the correct unit is amps. Lots to do there for the 3 marks. So we've got a rearranging, we've got making sure we're using milliseconds, and then we're getting the right unit. Metal appliances such as the lift button are earthed for safety. Explain why the man receives a shock even though the button is properly earthed. So metal is obviously a conductor. It will allow the electrons to flow through it. So there is a voltage. The only time you're going to get a flow of electrons is there is a voltage or a potential difference between the man and the button. It just told us that the man has a charge, but the button is earthed, so it doesn't have a charge. So if he has a charge and the button doesn't, there's a potential difference or a voltage between those two. And if there's a voltage, you're going to get a flow of electrons. So this means there is a flow of electrons, which is the shock. And there's our 3 marks. Notice that it's trying to lead you to that. This is our real SP stuff, because it's asking us to link together everything we've just done and explain why that shock is received. I think a lot of people here are going to say because there is a flow of electrons. This one is a really hard one to see, that there is a voltage between those two things, and that's why there is a flow of electrons. I think a lot of people will get 2 marks here, but we'll forget about that voltage difference causing the flow of electrons. And that's question number 7.